Hope all of you are doing well. Today's class we will start with the third sessions on metals and non-metals. In the previous two classes you have learnt a lot about the properties of metals and non-metals. Now let us have a recapitulation of what we have learnt in the second session. In the second session we learnt about the properties of metals and non-metals, that means the chemical properties of metals and non-metals, the activity and reactivity series of the metals and the reaction of metals with non-metals. And in this session we will learn about ionic compounds, how they are formed and their properties. Now we will start with the meaning and formation of ionic compounds. You know what are ionic compounds? These are the compounds formed by the transfer of electrons from a metal to a non-metal. So when a compound is formed by the transfer of electrons from a metal to a non-metal, this compound that is formed is known as an ionic compound, or it is also known as electrovalent compound. And there are certain examples, there are various examples for ionic compounds: sodium chloride, copper sulfate and magnesium chloride. These are examples of ionic compounds. Metals transfer electrons. All metals transfer electrons. After transferring the electrons, they become positively charged ions or cations. Positively charged ions are also called as cations. Whenever a metal transfers electrons from its outermost shell, from its valence shell, it loses one electron and gains a positive charge, and when it gains a positive charge, that metal atom becomes a ion. An ion, especially a cation. Since it gains a positive charge, it becomes a cation. So you can see examples: sodium and calcium. These are cations, Na plus Ca2 plus. Whereas when the non-metals receive the electrons, after receiving electrons, they become negatively charged ions or anions. When they receive electrons into their shells, an electron is added on and they gain an additional negative charge. That is why they gain a negative charge and they become charged ions, and since they are negatively charged ions, they are also called as anions. Chlorine, Cl minus, oxygen, O2 minus. So these are anions. Now let us recall what we learnt about the electronic configuration of elements in class 9. You have already learnt about the electronic configuration of elements in class 9. What do you remember out of that? You remember that noble gases, they show very little chemical activity. Why do they show that? Why do they show very little chemical activity? Because they have a completely filled valence shell. Their valence shell is completely filled. The reactivity of the elements or the metals is a tendency to attain a completely filled valence shell. Any element for that matter, they have to be reactive. If they have to be reactive, they have to have a tendency to either lose or gain electron. Either they have to lose an electron or gain an electron in order to obtain that complete valence shell or the noble gas configuration. So now let us have a look at the electronic configuration of noble gases and some metals and non-metals. Now you can see here, you can see the electronic configuration of helium, which is 2, the atomic number is 2, the number of electrons is 2, neon is 10, 2 and 8, argon 18, 2, 8 and 8. Now coming to the metals, sodium is 11, 2, 8 and 1, magnesium is 12, 2, 8 and 2, aluminium 13, 2, 8 and 3, potassium is 19, 2, 8, 8 and 1, calcium 20, 2, 8, 8 and 2. And now coming to the non-metals, nitrogen 7, 2 and 5. Nitrogen is 7, the electronic configuration is 2 and 5, oxygen is 8, 2 and 6, fluorine atomic number is 9, electronic configuration is 2 and 7. Phosphorus, the atomic number is 15, the electronic configuration is 2, 8 and 5. Now, let us see sodium. Sodium atom has one electron in its outermost shell. The atomic number of sodium is 11. You can see here the outermost shell has got only one electron. The valence shell of sodium atom has one electron in its outermost shell. If the sodium loses one electron from its M shell, then its L shell becomes the outermost shell and it will have a stable octet configuration. You can see here. So, if it has lost one electron, now the L shell becomes its outermost or the valence shell and that shell has a stable octet configuration. The nucleus of this atom still has 11 protons, but the number of electrons has become 10. So, there is a net positive charge giving us a sodium cation Na plus. So, since a nucleus, the nucleus of the atom contains the protons and the neutrons. The neutrons as it is, they do not have any electrical charge. It is the protons that have the electrical charge. The protons have a positive charge and in an atom the electrons have the negative charge. Generally in a neutral atom, the number of protons will be equal to the number of electrons. So, the positive charge and the negative charge will be equal. So, they will be cancelled and there is a net 0 charge or no charge for that atom. But now, when the sodium has lost one electron or negative charge is gone. So, the proton in the nucleus is as it is. That means 11 protons are there in the nucleus. So, 11 positive charges are there in the nucleus and in the shells you have 10 negative charges or the electrons because it has lost one electron. So, now 11 plus and 10 minus will give you 1 plus. That is why sodium gains one positive charge. So, and it becomes sodium cation. Now, you can see here electron that the sodium has lost will make the ultimate charge on the atom as Na plus. Now, let us see chlorine. Chlorine has 7 electrons in its outermost shell. It requires one more electron to complete its octet configuration. It has one electron short of the octet configuration. You can see here one electron is short for that octet configuration. If sodium and chlorine were to react, then the electron lost by sodium could be taken up by the chlorine. So, if sodium is giving one electron and the chlorine can accept that electron. Now, you can see here the sodium atom, it has got one electron in its outermost shell and the chlorine has got 7 electrons in its outermost shell. So, when sodium donates one electron or it transfers one electron, the chlorine can easily accept this electron. After gaining one electron, the chlorine atom gets a negative charge because its nucleus has got 17 protons and there are 18 electrons because it has taken up the electron that was given away by the sodium. So, the net negative charge has increased than the positive. So, 17 plus and 18 minus will give 1 minus. So, the chlorine becomes a chloride anion Cl minus. This give and take relation between sodium and chlorine is like this. See, you can see here sodium, its Electronic configuration is 2, 8 and 1. So, now when it becomes sodium ion, it gives away 1 electron. So, it becomes 2 and 8. Sodium cation has an electronic configuration of 2 and 8. Similarly, chlorine. Chlorine is taking that electron that was given away by sodium. Earlier chlorine had a electronic configuration of 2, 8 and 7. Now, chloride anion will have 2, 8 and 8. So, now you can see the transfer of electrons from sodium to chlorine and it forms sodium chloride. Sodium and chloride ions being oppositely charged. Sodium ion is positively charged and chloride is negatively charged, and since they are oppositely charged, they are attracted to each other and they are held by a strong electrostatic force of attraction. So, and they exist as sodium chloride, NaCl. So, this NaCl is formed by the attraction of two ions, that is why it is called as a ionic compound. It should be noted that the sodium chloride does not exist as a molecule, but aggregates of oppositely charged ions. So, now you can see here there is the ionic bonding. When sodium is giving away the electron from its outermost shell, chlorine is receiving that. There is a strong force of attraction that is being built between sodium and chloride, and that bond is called the ionic bond. Though there is a attractive bond, they are not together as you see in water. H2O, water is H2O, but they are so bonded that you cannot easily separate the. But in sodium chloride, though they exist together, they exist as sodium and chloride ions in the molecule. In the sodium chloride molecule, they exist as sodium and chloride ions with an ionic bond, strong ionic bond. Now, let us see the formation of magnesium chloride, which is another ionic compound. Okay. The atomic number of magnesium is 12 and the electronic configuration is 2, 8 and 2. It has got 2 electrons in the K shell, 8 electrons in the L shell, and the M, that is the valence shell, has got 2 more electrons. So, this valence electron is transferred during a reaction. So, when magnesium transfers 2 electrons from its M shell, it becomes Mg2 plus. So, it gains an overall average of 2 positive charges. Now, there are 2 more protons extra than the electrons that are present in the shell. So, that is why it gains a positive charge twice. So, Mg2 plus. Now, coming to chlorine. Atomic number of chlorine, as you already know, is 17. The electronic configuration is 2, 8 and 7. So, in the M shell, that is the valence shell, it has got 1 electron short of the octet configuration. The chlorine atom receives 2 electrons from magnesium, because magnesium is donating 2 electrons, but chlorine requires only 1 electron. So, 2 chlorine atoms receive 2 electrons from magnesium to get a stable electronic configuration. So, one chlorine atom receives 1 electron and another chlorine atom receives the other electron donated by the magnesium or transferred by the magnesium. So, thereby magnesium transfers 2 electrons and 2 chlorine atoms receive them 1 electrons each, and they get a stable electronic octet configuration. In the process, each chlorine atom gains a negative charge and becomes Cl minus. Now, you can see here magnesium is losing 2 electrons and it is becoming Mg2 plus, the magnesium cation. Chlorine is receiving 1 electron and it is becoming the chlorine anion. So, now you can see the entire process here. The magnesium, when it is donating 2 electrons or transferring 2 electrons, 2 chlorine atoms are receiving 1 each, and it becomes Mg2 plus and Cl minus twice. So, there are 2 chlorine atoms which receive the electrons and it becomes MgCl2, that is magnesium chloride. Now we saw how the ionic compounds are formed. Now let's study few properties of ionic compounds. Physical nature. Ionic compounds are solids. They are somewhat hard because of the strong force of attraction between the positive and the negative ions. So since there is a very strong force of attraction between the positive and negative ions, generally they are solids at room temperature. These compounds are generally brittle and they break into pieces when pressure is applied. They are hard, but they can break into pieces when you apply pressure. So you have all seen rock salt, sodium chloride, right? So that is quite big. So but when you apply pressure, that when you pound the rock salt, what happens? You can get powdered rock salt, but you cannot powder it to the extent of a flour, that atta, wheat flour or the rice flour. You cannot break it into that fine powder, but you can break it into small pieces. You can see here, this is candle and that is table salt or your sodium chloride. Sodium chloride is ionic compound, whereas the candle is not. It is a covalent compound. All ionic compounds have high melting and boiling points. This is because of the considerable amount of energy that is required to break the strong interionic force of attraction that exists between the positive and the negative ions, or the cation and the anion. The cation and the anion are bound by a very strong interionic force of attraction. That is why to break that it requires a lot of energy, and this energy is high, and therefore the melting and boiling points of the ionic compounds are very high. Now you can see a comparative table here which shows the melting and boiling points of few ionic compounds: sodium chloride, lithium chloride, calcium oxide and magnesium chloride. Sodium chloride has a melting point of 1074 Kelvin, whereas a boiling point of 1686 Kelvin. Whereas lithium chloride, you can see here, the melting and boiling points of all the ionic compounds are very high. Lithium chloride has 887 Kelvin melting point and 1600 Kelvin boiling point. Calcium chloride 1045 Kelvin of melting point and the boiling point is 1900 Kelvin. Calcium oxide has 2850 melting point and boiling point is 3120 Kelvins. Whereas magnesium chloride, the melting point is 981 Kelvins and the boiling point is 1685 Kelvin. From all this we can know that the ionic compounds have very high melting as well as boiling points. Now we can confirm this by conducting an experiment. We can heat the sample of the compound that we have to test the melting point in a spatula. So this is the experimental setup. You require a burner for that, and then you require a spatula, and in the spatula when you take a sample and you heat it with the support of the burner, then you can find out whether the sample that you have taken has a low or high melting point. And now coming to another property, solubility. Solubility is the dissolution property of the compound. Electrovalent compounds or ionic compounds are generally soluble in water and they are insoluble in solvents such as kerosene and petrol. They can dissolve in water but not in organic solvents like kerosene and petrol. And conduction of electricity. Ionic compounds conduct electricity in the molten state. They generally do not conduct electricity in the solid state as it is. They can conduct electricity in the molten state or in the solution state. So this is how you can check the conductivity of the ionic compound in the solution state. So, this is the experimental setup required to test the conductivity of the salt solution. So, you require a beaker and you require 2 graphite rods and then a bulb and a battery. And when you take the solution of the water to be and then you take the salt solution in the beaker and you have to test it. If at all the salt solution is going to conduct electricity, the bulb will glow, and if it does not, then we can understand that the salt solution does not conduct electricity. Why do you think in the molten state the ionic compound can conduct electricity? That is because in the molten state the electrostatic force of attraction between the cation and the anion, they are overcome due to the heat. So, thus the ions move freely and they can conduct electricity. Ionic compounds in the solid states, they do not conduct electricity because the movement of the ions in the solid is not possible due to its rigid structure. All solids have very rigid structure, and in this rigid structure the ions are not able to move. So, there is no possibility of movement of the ions, and you know that the electricity is the flow of electrons, and that is why it is not possible in the solid state. Let us perform certain activities and find out whether the properties of ionic compounds what we discussed are true or not. I have taken 3 compounds here. This is sodium chloride, this is barium chloride, and this is potassium permanganate. So, all of you know that these are solids at room temperature, and I told you they are hard but they are brittle. See here. So, I can just, this is sodium chloride, your table salt. Whatever I do, I can just break it into more pieces, but not into the flour like consistency that you have seen, that a fine powder you cannot make with this ionic compounds. Now, let us check the electrical conductance of these compounds in the solid state. See here. So, this is an electric circuit, and if it conducts electricity, then the bulb should glow. Now, this is not conducting electricity, this is in the solid state, and now this also is not conducting electricity, this is also not conducting electricity in the solid state. Now, let us see if it conducts electricity in the solution state. For that I will add some drops of water to this to make a solution. Now, let us see if it conducts electricity. Now, see here, it is conducting electricity after I added the water. And now, coming to this barium chloride, this is also conducting electricity after I added the water. See here, this is also conducting electricity in the solution state, but in the solid state none of them conducted electricity. You can see the bulb glowing here. Now, let us check the melting points of salt, which is an ionic compound. I am taking this in a spatula. I am just heating this. See here, it is not melting. So, you could have seen this. See, you are not able to melt it. At the most it will crackle, but it will not melt. Now, let us see if we can melt sugar. See, this is sugar. I think all of you can see here, sugar is melting. The sugar melted with this amount of heat, but you could not melt the salt. Let us test the solubility of the ionic compounds in, see, this is salt. I have taken salt in these two glasses, and for one glass I am going to add water. And in another glass I am going to add kerosene. Now let us see if the salt dissolves in water. Now you can see here the salt has completely dissolved, and in this kerosene we will check the solubility. See, no matter whatever amount of stirring I do, I am not able to dissolve the salt in the kerosene. You can see here the salt remains as it is. See here, the salt remains as it is not getting dissolved in the kerosene. Now let us have a small recapitulation of whatever we have learned till now. Atoms of elements either lose or gain electrons in order to obtain stable or octet configuration, and they become ions. Due to the attractive force between the ions thus formed, ionic compounds are formed. The properties of ionic compounds, we will just have some highlights. They all dissolve in water, they have high melting and boiling points, they conduct electricity in molten state or the solution. And it is time for your assignment. Write the electron dot structures for sodium, oxygen and magnesium. So, this you have already learned to write the dot structures of electrons. So, you have to write the electron dot structures for sodium, oxygen and magnesium atoms. Another one, show the formation of sodium oxide and magnesium oxide by the transfer of electrons. So, now what are the ions present in these compounds? You have to write the names of the ions that are present in these compounds, sodium oxide and magnesium oxide. Why do ionic compounds have high melting points? So, this we have already discussed in the lesson. Now, you have to remember and write why do ionic compounds have high melting points. There is another question. An element reacts with oxygen to give a compound with a high melting point. This compound is also soluble in water. The element is likely to be, you can choose from the options, calcium, carbon, silicon or iron. Think and answer this question. I hope all of you could able to know the properties of the ionic compounds, what they are, how they are formed. I hope all of you could know what are ionic compounds, how they are formed and the different properties of ionic compounds. In the next class, we will meet and we will discuss what are the properties of metals and also what is metallurgy and the different processes involved in metallurgy. Till then, bye. All of you, take care that you do all your assignments and show to your teachers. ಇದಿದೆ.